What's going on, everybody? Welcome to another session of Deep Coding. Today, we are going to talk about earliest possible day of full bloom. In this problem, you're given n flower seeds, and each seed has a plant time and required grow time. After grow time, the seed is bloom. So you're asked, what is the earliest possible day where all seeds are blooming? We have a couple of constraints here. Every day you can only work on planting exactly one seed, and also after planting is done, growing starts right after that. How we can solve this problem? Before we get into this problem, let's think about it in this way. Let's say we didn't have any grow time, we were just working with plant time. If a seed has a specific amount of plant time, you have n seeds, no matter what order you're taking, at the end of n seeds, you're going to take a fixed number of days. But right now, we have a grow time incorporated in that. To take grow time into account, let's look at this example. Let's say you start with the first seed that takes just 1 day for planting and 3 days for growing. After planting the first seed is done, the growing starts. But at the same time, as you can take a look here, the planting of the second seed starts. So the first 3 days, while the first seed is growing, I'm working on planting my next seed. Same thing happens on third and fourth and so on. So basically, we have some parallel tasks happening here. To optimize this or to minimize the number of days required to have all the end seeds bloom, we need to think about it, that we need to start with the seed that has longest number of days to grow, because while I'm working on the second seed, it starts growing the first one, and then while I'm working the third seed, the first one is still growing. So if I start with the seed that has longest amount of grow seed, at the end I'm getting to a point that I have the minimum number of days. Because my goal in this channel and this set of videos is that it gets you to coding part as soon as I can. Let's dive into coding, and I can explain it while I'm coding it. So, okay, let's dive into coding. So first, let's take in from plant time. I could take it from grow time because basically they're of the same size. So what I do, I make a vector of pair of plant and grow time, and then I would like to sort them decreasingly based on grow time. To do that, I create a vector of pairs, integer and integer. Let's call it plant grow. That would help me understand the first element in my vector is plant time, and the second element in the pair is grow time. And actually, let's give it a size n because we have n elements or n seeds. And I iterate through all my elements, and feel plant grow I is going to be plant time I and grow time. So I fill my vector of plant time and grow time. Now these two times are attached to each other. Now that I want to sort the elements, I don't lose them. So if I'm sorting based on the grow, the corresponding plant time is attached to it. So I sort this plant grow that begin and plant. I sort the entire vector, but my sorting has my own element 1, element 2. So my sorting has my own rule. I would like to say saved or sorted in decreasing manner. So if one dot second is greater than e2 dot second, basically I'm saying if you're looking at two different elements and if the first one has a higher growing time, then just keep it at the beginning. And as we are moving through the plant grow vector, the grow time should reduce. Now that I have my plant growth sorted based on growing time in decreasing manner, all I need to do, I need to create a rest and current time. Let me show you what do I mean by these two values. Let's say the first one takes this amount of time to plant, this amount of time. Let me actually, this amount of time to plant. and then grow. And the second seed, right after I'm done with planting the first one, I start planting the second one, and then when I'm done, growing starts. So that would be my plant two and growing two. And then I could have this third one right after the planting is done. I can start planting the third one and then it starts growing. So at the end of each time, that I would save this time in rest, which would be plant time plus grow time. And my current time that I just showed you shows what is the latest day, last day that I finished planting the previous seed. So P1 days, it would be saved in current time. And now that I start working on second seed, the time that I'm finished would be current time plus P2. It will stand here. And then same thing here. And for the last time here, for the final result, I'm looking for this time exactly. But how I can get to this part is that, for example, in this case, this would be current time that I've saved so far plus planting time of the third one plus growing time, and then at the end would be my rest. So I get the maximum value of this. Let's see how we can do that. For each of the elements in plant grow, the current time would be the planting time. I add the planting time to it. And also for result would be the maximum result that I can find. P dot second, which would be the growing time, and plus current time. Yes. Let's run it to see if it's work. Yes, and submit. Accept it.